Good morning, students. Today we will continue our chapter 2, that is electric potential. We will find electric potential due to an electric dipole. What is electric dipole? See, minus Q plus Q, two equal and opposite charges separated by finite distance 2a, then it will form electric dipole. O is the center of electric dipole. P, electric dipole moment. What is direction of electric dipole moment? From minus Q charge to plus Q charge, means in this direction. Okay. Now we have to find what is potential due to electric dipole. So we are taking one point A at distance r, from center O. At distance r from center O. Okay. Take the origin at center of dipole. Find potential at point P at distance r from center O. We are also assuming one data. See, from center O, position vector of A is r in this direction. P, dipole moment, it is vertically upward direction as shown in figure. What is angle between r and P? We are assuming theta. Okay, let theta is angle between P and r. Now we have to find what is electric potential at point A. You have to ask one simple question. Potential is due to charges. So at point A, potential is due to plus Q charge and due to minus Q charge. Then how to write? See, V is equal to V plus, means potential due to positive charge, plus potential due to negative charge according to superposition principle. Okay, what is equation of potential for point charge? We have obtained in last lecture. For positive charge it is 1 upon 4 pi epsilon 0 Q upon R1, where what is R1? R1 is distance of point A from charge plus Q. Clear? Similarly, plus 1 upon 4 pi epsilon 0 minus Q upon R2, where R2 is distance of point A from minus Q charge. Clear? Q upon 4 pi epsilon 0, Q upon 4 pi epsilon 0 common. So in bracket it is 1 upon R1 minus 1 upon R2. Name equation number 1. Now you have to find equation of 1 upon R1 and 1 upon R2. First of all, we will find equation of 1 upon R1. See in figure here. See, it is A in this direction. It is A. R1 and another vector is this R. What is angle between this A and R? Theta. See, here it is. Here it is. A, R, and it is R1. What is angle between A and R? It is theta. Clear? So we can say from figure, see, 1, 2 and 3. Three vectors, and see relation between them. Tail, head. So A plus R1 is equal to R. You know what is graphical method, triangle method for vector addition. From this figure you can easily write relation between these three vectors, that is A plus R1 is equal to R. Then A plus R1 is equal to R. Make R1 as subject, then it is R minus A. Clear? Now we have two vectors and its resultant is R1. So according to law of parallelogram, how to find its magnitude? R1 square is equal to R square plus A square minus 2AR cos theta, where theta is angle between A and R. Clear? Again, see, R1 is equal to R minus A, okay, so what is its magnitude? R1 square is equal to R square plus a square minus 2ar cos theta. If you know equation r is equal to a minus b, then r is equal to under root a square plus b square minus 2ab cos theta. So from that equation you have to write this. Now see, take r square as common from right hand side. Then if you take r square common, here it is 1, you have to divide r square to each and every term. R square divided by r square, 1. A square upon r square minus 2ar cos theta upon r square. So 1r and 1r will be cancelled out. So it is 2a cos theta upon r. Again, whenever you take common any term, you have to divide with each and every term. R square divided by r square, 1. A square upon r square minus 2ar cos theta upon r square. Then it is 2a cos theta upon r. Clear? Now, this theory we are taking for small dipole. Small dipole or for a point at large distance. For a point at large distance. So for point at large distance we can say r is very greater than a. Then with respect to r, if you take a square upon r square ratio, it will be nearly 0. When r is very greater than a, see, r is very greater than a, means here a square upon r square, denominator will be large, and you know that when denominator is large compared to numerator, answer will be nearly 0. Yes, so here a square upon r square you have to write 0. Then what is your term? r1 square is equal to r square 1 minus 2a cos theta upon r. Clear? Okay. Take square root. r1 is equal to r 1 minus 2a cos theta whole term raised to 1 by 2. Clear? Any doubt? Okay. Next. 1 upon r1 is equal to 1 upon r 1 upon 1 minus 2a cos theta upon r whole raised to 1 by 2. Okay, take its reciprocal. 1 upon r1 is equal to 1 upon r 1 upon 1 minus 2a cos theta upon r raised to 1 by 2. 1 upon r as it is, 1 upon r1 as it is, 1 upon r as it is. Now see how to write this term. Okay, if you take this term in numerator, then how to write? 1 minus 2a cos theta upon r raised to minus 1 by 2. Now, this term you have to remember. See, using binomial theorem and retaining terms up to first order E upon r. Why first term only? Because here we have assumed r is very greater than a. See students, binomial expansion, binomial theorem we have already studied in 11th in chapter number 8, gravitation. In gravitation, what is long method that you already know, but how to just make it simple, how to remember, it is easy. See, what is trick? If you are given r is very greater than a, then how to expand this term? See, this minus 1 by 2 power you have to multiply with second term. See, 1 upon r1 as it is, 1 upon r as it is, 1 as it is, minus 2a cos theta upon r. This minus 1 by 2 you have to multiply with second term. What is reason? That we have already discussed in 11, if you remember. Okay, then 1 upon r1 is equal to 1 upon r, 1, 2 cancel, minus plus a cos theta upon r. If you multiply this 1 upon r inside bracket, then 1 upon r into 1 upon r, a cos theta r into r, it is r square. Clear? It is value of 1 upon r1. Now with the help of similar method, you have to find 1 upon r2. 1 upon r2 you have to find by yourself. See, just figure. Similarly from figure, see what is figure here? What is figure? It is A in this direction. R2. We have assumed this point A, it has large distance. So if angle between R and A is theta, angle between R2 and A is also theta, because this point A is at large distance. This point A is at large distance. So we can say that this R1, R and R2 will almost be parallel. So if R makes angle theta with A, R2 will also make angle theta with A. Let's see, figure here, A, R and R2. Again, three vectors, triangle method. What is relation between them? A plus R is equal to R2. Then R2 is equal to R plus A. R2 is equal to R plus A. Now see how to obtain equation of 1 upon R2 by yourself with a very small change. See here. What is equation of R2? R plus A. What is equation of R1? R minus A. See what is difference? R plus A, R minus A. Then see, in this simplification, you have to do only one change. See, R2 is equal to R plus A. According to law of parallelogram, R2 square is equal to R square plus A square plus 2AR cos theta. Plus here it is plus into minus, means here your answer will be minus. Okay, and therefore this term will be minus. So you have to obtain equation of 1 upon R2 by yourself. You have to obtain equation of 1 upon R2 by yourself. 1 upon R2 is equal to 1 upon R in bracket 1 minus A cos theta upon R is equal to 1 upon R minus A cos theta upon R square. So from these three equation number 1, 2 and 3, how to write potential? V is equal to Q upon 4 pi epsilon 0, value of 1 upon R1 minus value of 1 upon R2. Between two terms, it is negative sign. So you have to change sign of 1 upon R2. 1 upon R1, 1 upon R. Cut. So Q upon 4 pi epsilon 0. A cos theta upon R square, A cos theta upon R square, it will be 2A cos theta upon R square. Now we know that Q into 2A is electric dipole moment. So Q into 2A is equal to P cos theta 4 pi epsilon 0 R square. Clear? Now P, electric dipole moment vector quantity. R, that is position vector, is also vector quantity. See, if you know one equation here, A dot B is equal to AB cos theta. A dot B is equal to AB cos theta. A, magnitude of A, vector A. B, magnitude of vector B. And theta is angle between them. Theta is angle between them. If I say B vector is unit vector, then how to write? A dot B caret. If B is unit vector, then is equal to magnitude of A. B caret means unit vector, its magnitude will be 1, then it is cos theta. Okay, then if A cos theta is equal to A dot B caret, A cos theta is equal to A dot B caret. Here we have term P cos theta. And what is theta? Angle between P and R. Then how to write this P cos theta? P dot R caret. P dot R caret. Okay. If you take reverse, P caret, P vector, what is its magnitude? P. R caret, what is its magnitude? 1. And angle between them is theta. So it is cos theta. So P dot R caret is equal to P cos theta upon 4 pi epsilon 0 R square. So it is equation of potential due to electric dipole. Pause your video and write down in your notebook. See, we have obtained equation of potential due to electric dipole. V is equal to 1 upon 4 pi epsilon 0 P dot R caret upon R square. So we can also write is equal to 1 upon 4 pi epsilon 0 P cos theta upon r square, where what is theta? Angle between P and R. Okay, we have obtained this equation. Now you have to consider two special cases. See, again electric dipole, minus q charge plus q charge. Electric dipole moment is from negative charge towards positive charge. We know that it is called axis of dipole, and this perpendicular bisector is called equator. Okay, if on this axis I am taking one point here, on the left hand side of plus q charge, then from this center, what is its position vector? In this direction. So see, from figure, R and P, they are in same direction, means angle between them is 0. If angle between them is 0, then cos 0 is equal to 1. Then V is equal to 1 upon 4 pi epsilon 0 P upon R square. Clear? Okay. So on side of plus q charge, potential is positive. Now if point is on this side, here, okay, on side of negative charge, then with respect to this center, position vector is in this direction. Okay, so from figure it is clear, P and R, they are in opposite direction. Angle between them, theta is equal to pi 180 degree, and we know that cos 180 is equal to minus 1. So potential will be negative. So how to remember? On side of plus q charge, potential is positive. On side of minus q charge, potential is negative. Okay, so it is on axis of dipole. Now what is potential on equator? See, if I am taking one point here on equator, then from center its position vector is in this direction. So R and P, they are perpendicular to each other. From figure it is very clear. R and P, they are perpendicular to each other. So on equator, theta is equal to 90 and cos 90 is equal to 0. So potential is equal to 0. See, for each and every point on equator, potential is 0. 2 points you have to remember. V means potential depends on theta, angle between P and R. And second, in case of dipole, for large distance, what is relation with distance? V is proportional to 1 upon R square, not as 1 upon R. For point charge, it is 1 upon R. But for dipole, it is 1 upon R square. V is proportional to 1 upon R square. So here theory is what is potential due to dipole. Clear? Any doubt? If you have any doubt, then we'll discuss in our video lectures on Zoom. Okay. Now, it is potential due to dipole. Next topic is potential due to system of charges. If you are given Q1, Q2, Q3, Q4, dash Q1 charges, and you want to find what is electric potential at point P, then it is simple. See, consider system of charges as shown in figure. By the superposition principle, potential at point P due to the total charge configuration is the algebraic sum of potentials due to individual charges. At point P, how to find potential? Due to Q1, due to Q2, Q3, dash Q1. Okay, so V is equal to V1 plus V2 plus V3 plus S2 plus so on. So V is equal to V1 1 upon 4 pi epsilon 0 Q1 upon RP1, where RP1 is distance of point P from Q1 charge. 1 upon 4 pi epsilon 0 Q2 upon RP2 again distance of point P from charge Q2. So potential is scalar quantity. So you can take their algebraic sum. As we add mass, we can add this potential. So it is potential due to system of charges. Next is potential due to uniformly charged spherical shell. Potential due to uniformly charged spherical shell. See, you are given one spherical shell of radius r having charge q. Having charge q. Now again, in chapter 1, we have obtained electric field due to spherical shell. Outside, inside and on surface. Similarly, you have to find electric potential. Okay. First of all, we will find outside for r greater than r. We have obtained one result. For r greater than r means outside. We can say that the total charge on spherical shell is concentrated at its center. At its center. So from center at a distance r, what is potential? We know its equation. V is equal to 1 upon 4 pi epsilon 0 q upon r, where r is distance from center. R is distance from center. So for outside it is easy. For outside point, entire charge is concentrated at its center. So V is equal to 1 upon 4 pi epsilon 0 q upon r. On surface you have to replace this small r by its radius. Then V is equal to 1 upon 4 pi epsilon 0 q upon capital R. Now, inside means r less than r. R less than r. Potential is constant inside shell and equals to its value on surface. That is V is equal to 1 upon 4 pi epsilon 0 q upon r. How? See, potential means it is work required to bring unit positive charge from infinite distance to given point. If I am taking one point inside, it is inside point. Suppose it is a distance r. Okay. If I want to find potential at this point, I have to bring unit charge from infinite distance to this point. Okay. Total work. Potential is nothing but total work. Total work. Now I divide this whole work in two parts. First, work required to bring unit positive charge from infinite distance to one surface, and from surface to inside. From surface to inside. What is work required to bring unit positive charge from infinite distance to surface? Potential on surface. So this work done, W1 is equal to 1 upon 4 pi epsilon 0 q upon r. Now we know that inside spherical shell electric field is 0. Inside spherical shell electric force is also 0. And as force is 0, no work is done. So to bring the charge from surface to inside, work W2 is equal to 0. Clear? So what is total work to bring unit positive charge from infinite distance to a point inside? W1 plus W2. So it is 1 upon 4 pi epsilon 0 q upon r. In short, you have to do work to bring unit positive charge from infinite distance to one surface. From surface to a point inside, any point inside spherical shell, work done will be 0. Work done will be 0. So here you have to remember this point. Okay, on surface and inside, at each and every point, potential is same. V is equal to 1 upon 4 pi epsilon 0 q upon r. V is equal to 1 upon 4 pi epsilon 0 q upon r. So it is potential due to spherical shell. Clear? Pause your video, write down from board, make proper notes, send notes on my WhatsApp number. For other school students, send notes to your respective subject teachers. Thank you. See students, one question based on superposition principle of electric potential. You are given one system of charges. See, Q charge, minus Q charge, minus Q charge. and here it is q charge. Now see, this minus q charge and minus q charge, they are very close to each other. They are very close to each other. Okay, so we have total 4 charges, q, minus q and q. As we have a system of 4 charges, this system is called electric quadrupole. This system is called electric quadrupole. See, quadrupole, we have 2 dipoles. 1 minus q plus q, 1 minus q plus q in opposite directions. Okay, now see, this minus q charge, as they are very close to each other, I can indicate them or I can represent them as a one charge that is minus 2q. That is minus 2q. Clear? So now we have total 3 charges, q, minus 2q and q. And on its axis, at this point P, we have to find what is electric potential. We have to find what is electric potential. Distance of this point P from this minus 2q charge is r. Distance between this charge is a. Distance between this charge is a. Now according to superposition principle, see, potential at point P is due to this q charge, this minus 2q charge and this q charge. See, it is very simple how to write. Vp is equal to, first of all, due to this charge, 1 upon 4 pi epsilon 0 q. What is distance of this charge from point P? This total distance is r and this distance is a. So r plus a. It is distance of q from P. Clear? So its distance is r plus a. Now for minus 2q charge, 1 upon 4 pi epsilon 0 minus 2q. What is distance of point P from this minus 2q charge? R. Simple. For this q charge, 1 upon 4 pi epsilon 0 q, this total distance is r. This distance is a. So what is distance between P and this q charge? It is r minus a. From figure it is very clear. It is r minus a. Now you have to simplify mathematical steps. How? Q upon 4 pi epsilon 0 common. Then from this first term, 1 upon r plus a. From this second term, minus 2 upon r. From this third term, 1 upon r minus a. Okay, now I am writing these two terms together. See, Vp is equal to q upon 4 pi epsilon 0, 1 upon r plus a plus 1 upon r minus a minus 2 upon r. First of all, I will simplify these two terms. This term as this, r minus a into 1, r minus a plus r plus a into 1, r plus a. Divided by r plus a, r minus a, so it is r square minus a square. Minus 2 upon r as it is. A cancel. So this term as this, r plus r, 2r upon r square minus a square minus 2 upon r. Q upon 4 pi epsilon 0 as it is. Again, cross multiplication, 2r into r, 2r square minus, that is minus sign. Okay, so 2r square minus 2r square, and as this a square is minus plus 2 square. 2r square cut. So Vp is equal to q upon 4 pi epsilon 0, 2a square r square minus a square. Now in question you are given, okay, distance you have to take at very large distance. R is very greater than a. R is very greater than a. So in this denominator, in r square minus a square, as r is very greater than a, r square minus a square will be nearly equal to r square, or you can take a is equal to 0. So if you take a is equal to 0, then r into r square, it will be r cube. So Vp is equal to q upon 4 pi epsilon 0, 2a square upon r cube. It is equation of potential due to electric quadrupole. You have to remember one point. Q into 2a square is called quadrupole moment. Is called quadrupole moment. Now, again one question. So what is variation of potential for a point charge, for electric dipole, and for electric quadrupole? See, for electric quadrupole, V is proportional to 1 upon r cube. 1 upon r cube, we have obtained equation. Vp is equal to q upon 4 pi epsilon 0, 2a square upon r cube. So potential varies as 1 upon r cube. As 1 upon r cube. For a point charge, V is proportional to 1 upon R. And for dipole at large distance, that is R very greater than A, V is proportional to 1 upon R square. This each and every statement is MCQ. Okay, what is variation of potential for point charge? What is variation of potential for electric dipole? What is variation of potential for electric quadrupole? You have to remember each and every equation and each and every relation for potential as well as from first chapter for electric field. Clear? Pause your video. Write down in your notebook. Make notes. Send notes on my WhatsApp number. And other school students, send notes to your respective subject teachers.